All right, in lesson 10, we're going to continue our training on collections. But the difference here is instead of just making a very generic list of items, we're actually going to make a dictionary. So we want to actually have a key that we're going to use, whether that's a string or an integer number, but some sort of key that is going to look up inside of a collection. And based on that key, it's going to give us some other type of data. What are good examples of why we would do that? If you actually think of the word dictionary, you go up and alphabetically you're searching for a particular word and you want to get the definition based on that word that you're looking up. Well, it's kind of the same concept. We have a collection in memory that is going to allow us to pass a keyword or a number to it, and then it's going to return some other additional data based on that key. So in the terms of the Tekla world, why would I use that? Well, I may want to store a list of identifiers, or like for model objects, or GUIDs, globally unique identifiers or IDs. And essentially, I'm going to store those in a list, and I may have that list based on selected objects in the model, and I want to go fetch in the API and the database based on that GUID. I want to get deeper, part information and things like that. So the whole idea is that you're keeping a high-level list of keys, and then you want to go look up a deeper level or definition of data. All right, so let's go ahead and dive in and take a look. What I want you to do is create a new Windows Forms application, create a button here called button_lookup. So you can see that I've actually changed the name here to button_lookup. And that's going to be the event where we actually look up something in the dictionary based on the text field that we fill in here. So again, we'll call this text_lookup for a text field. And then we'll just have a label results like we've been doing in previous applications. I'm going to go ahead and pause the video, get your form set up, and then we'll dive into the code. All right, now to execute this code, let's actually just click on the form, and up here in the header where it says the title that I show, I'm just going to go ahead and double click on this. It'll create the form load event, and very similar to the previous exercise, we're just going to add a class level variable here that's going to be our dictionary. So we'll type in dictionary. You'll see that there's an open and close caret, just like we did with the list, but the difference here is when you look at the IntelliSense, it's expecting a key and then value pair. So in the list, we were just adding a string. Here we need to add a key and then a value that's associated with that key. And what key means is just think of like a lock on a door. You have a specific key that will only work in this lock, and when you unlock that lock and open the door, you get the whatever's behind that door, the prize behind the door, or you can get inside the car. And it's the same philosophy here. So you have a unique key that will then return some sort of value that's associated with that. So I'm going to say that the data type for the key is going to be string, and then we can also say that the value that's returned is a string. So what are we going to call this? Like what is a good example of this? Well, a very common thing that you can think of is an address book, right? So I can say that let's just call this dictionary name and addresses. Okay, and we'll just do a semicolon at the end. So we're just declaring this basically this class level variable, and we're going to use this across multiple code blocks in this application. Now down in the form load event, we're just going to instantiate this as an empty dictionary. So name addresses equals new, and again that new is basically just an instantiator keyword to create that new empty list. And there we go. So when this application starts, it's going to create a new empty name addresses dictionary. Now what I'm going to do is I'm going to go back to my form designer, and I'm going to double click on this lookup code. And so when the user presses this, it's going to look up based on the text string that has been entered in the text box on the form UI. And it's going to go check and see if this name exists in the name addresses dictionary. Now, before we actually do any code, let's add just a few name and address key and value pairs. So we're just going to say name addresses dot add, and notice instead of just one string, I'm adding a string key and then a resultant value. So I'm just going to say Chris is my name, and my address is 2345 North Street or something like that. And there is my first basically entry or key value pair. So if I know my name is Chris and I want to find my address, basically this is a dictionary that is a lookup table for that. So I know Chris, I want it to search through the collection, find my key name, and then return the address to me on the UI. So let's do name addresses again, .add, and we'll just add Bob, and we'll just say 3456 South Elm Street as an example. Okay, and then let's do one more, name addresses .add, and we will say Jim, and we'll say 3479 Southeast 10th Street. Okay, so we have a few different addresses, and now the way dictionaries work is essentially the key has to be unique. You can't have two Chris's in here. So the key value has to be unique. The value that's associated with that and returned in the dictionary can be, you can have multiple 2345 North Streets, like multiple people could live at that same address, but the key that you're using to look up in the dictionary has to be unique, okay? So we've added those, so when the form gets loaded and this application starts, this name addresses dictionary is going to get created, and we've added 3 hard-coded names and addresses to that. Now, what I'm going to do is I'm going to go ahead and do a search. So I'm going to say, basically, I want to check and see if name addresses contains the text name that somebody's filled on the UI. So I'll start with, again, a conditional statement, right? And in fact, before we even do that, let's just say string name on UI. So UI just means user interface. And so we'll say equals, we're going to say text underscore the lookup value. We'll say text field from that text box. And again, this might be a good case where what if somebody types in Chris all capitals? I probably should make this actually like this. So Chris, Bob, or Jim. And then basically I should just go ahead and make this .to upper. Okay. Now what I'm going to do is I'm going to just say if name on you, if name addresses dot contains, and notice that there's a contains key or contains value. So you can actually do lookups and conditional checks based on either the key or the value. Now I'm going to say contains key, and I'm going to say name on UI. Now, if it contains basically the name addresses, or the address book contains the name that I'm looking for, then I'm going to return the address. If it doesn't, then basically this name doesn't exist in there, and so I should just skip over the code and not do anything. Or I can go ahead and we'll do this. Let's do an else statement, and we'll just say that if the name is not in the list, we'll just say label results.text name not found. There we go. And so if the name is inside the list and we found it, then we need to go get it. So I'm going to say label results.text is equal to name addresses, and then again you use the square brackets here and you enter in the string key. So what the key value is the name on the UI that somebody entered in on the text box. And we're going to go ahead and use that as basically the lookup key and go get that from the address book. And then when we use that key, it's going to return the address to us, and we're going to show that here on the label results text field. Okay, so if you need to pause that and take a look at the code before I run this, feel free to do so. I know I'm combining a few different things that we've done in some of the previous videos. So here we're actually using that if statement logic, if and else. So if this is actually containing the address book contains the name, then let's return the address. If not, let's tell the user that we couldn't find it. All right, so let's go ahead and run this code. And in fact, if I just say lookup right now, it says name not found because I didn't enter in anything, right? So let's just go ahead and put in, say Nathan as an example, and lookup name not found. All right, well, let's try Chris. Lookup, and there it is. There's the street, right? 2345 North Street. So basically it found it, and notice that this is in partial capital, partial lowercase, but it found it because I did a to upper of this, and then it looked that up in the address book and it found a match. So this is again one of those examples of where I was showing in the previous videos where using the to upper on strings when you're trying to do lookup tables or check things in lists and things like that based on input from the UI versus what's actually behind the scenes in your code, you want to basically make sure that the user can't enter in the wrong thing. All right, so there you go. This shows you an example. Let's actually do a lookup for Jim. And we'll say lookup. And there we go. We can see that address has also been returned. Now, one other thing here that's important is what happens if I tried to look up something that did not exist in the address book. And that's why I put this code here. So if I try to find something that does not exist, an exception is going to be thrown. And I showed that in the previous video where I tried to pass basically index 99 on a list, and that was too high of a number versus the number of strings and items that were in that list, and it threw an exception. The same thing would happen here. So these are just good coding practices and things that you have to learn, so that way exceptions can't be thrown, and that you're kind of checking that the input that's coming from the user interface can actually work and won't throw any exceptions in your code. Okay, so now I've modified the code here to actually show another type of similar dictionary collection here, and it's called a hash table. And the only reason why I'm showing this is because the Tekla API actually implements some of these older collection types like Hashtable. I've almost should have shown this in the list collections video as well, where there's things like arrays and array list, because that's in the Tekla API as well. But I'll cover those more specifically when we get to the Tekla API training. Now, here I want to show this just because it gives you an understanding that the Tekla API was created and originally released, I believe, back in like 2006 or 7. And so .NET, for earlier versions of the .NET framework or earlier versions of C# essentially had older implementations, and then kind of the language has evolved over time. Now, the things I've been showing you so far in the training series on collections like dictionaries and lists, these are generic collections, and these are a lot more robust and better things to use when you're actually doing your coding. But because the Tekla API implements some of these old methodologies from earlier .NET frameworks, it's important for me to show you this. Now, when you create a new Windows Form application, by default, it actually calls out this namespace declaration for system.collections.generic. And things like dictionary or list, they actually live in that system.collections.generic. So when you actually look at the IntelliSense here and you hover over dictionary, you'll see the full namespace path of the class library in the .NET framework that this type of object dictionary lives under, system.collections.generic. Now, I've already modified the code, but there's an older form of collections underneath system.collections that has like Hashtable or array list or arrays and things like that are stored in there. Now, this is, again, a little bit older school. Both implementations will work. You can do a lot more with generic collections, especially when you do searching and filtering and things like that later on, which these older collections do not have as easy things to use to do that type of stuff. But I want to show you both implementations so you can understand it, because you will face this in Tekla structures. Okay, so I fully wrote the namespace system.collections.hashtable here just so you could see the difference between the two. But let's actually get rid of that. So if I cut this out, notice it can't even recognize this. The compiler's like, what is this? So all I need to do is, so I don't have to fully declare that out, is I'll just put a using statement at the top of the code here, and then I'll just say system.collections and then put a semicolon. So now it recognizes the hash table object. Now I've essentially done the same implementation as the dictionary, but notice one key difference here. Hashtable does not have a data type declaration for the key value or for the index. It can be anything you want. Now, that's kind of good, but it's also kind of bad. If you're really specifically trying to set the code to do a certain thing and expect certain types of keys and output certain types of results, it honestly is a lot better to use dictionary and explicitly do this like I show here. But I'm just going to show you this example because, again, you're going to face this when you're getting like report values or user-defined attributes from objects in the Tekla model. All right, so here we have Hashtable. Again, I've commented out the dictionary code so you can pause the video and you can compare the differences between the code. Honestly, it looks almost exactly identical from the instantiation of the hash table versus the dictionary, except for, again, I'm not passing the data types. But here I'm just adding a key value pair, so the names and then the addresses. And when I go to the lookup code, again, you can also just see where I've commented the code versus and the differences between them. Essentially, I'm still looking up for that contains key, and I'm looking at that name on the UI from the hash table. But the difference here is I actually have to do a thing called casting. Okay, so because I didn't explicitly or specifically declare the data type of the values that could be in the hash table, it can be kind of anything. I actually have to specifically say that, hey, when I'm looking up this name, I am trying to convert whatever the returned value or object based on that key of the name is going to be a string address. It's not going to be a number or a digit. It's going to be a string value. And so by putting string here at the beginning, that explicitly is converting that value to string, which then can be used to text. So this is more technical. Again, you know what I mean? Like it involves more work kind of downstream, has more potential for error and exception and error handling that needs to be kind of dealt with. So I don't like this, and this is an older implementation, but you can see the differences between the older .NET framework or older C# coding style versus the newer one, which is going to use dictionary. So hash table is the old way and dictionary is kind of the newer way.